Okay, so today we're going to solve the flower problem. And as you remember, the conditions were that you had to buy 12 roses in a bunch and 8 lilies in a bunch. And part A of the problem asks for us to find when we can have an equal amount of roses and lilies. How many bunches we would have to buy of each. To find that, most of you did found the least common multiple. You took the 12 roses and you took the 8 lilies, and then you started finding multiples. And you could keep going. Okay, and then we did the same with multiples of 8. 8, 16, 24, 32. Wait a second, I remember 24. So this is a common multiple, and it is the smallest one, therefore it's called least common multiple. We could find other multiples. In part B, they ask you all the different possibilities that they could have bought, and now I see that 48 is also a common multiple. It's not the least common multiple, but it is a common multiple. If I kept going, 56, 64, 72, 80, 88, 96, and we said that it couldn't be more than 100, so now I'm done. And 24, 36, 48, 60, 72, that's another common multiple. 80, 84, excuse me, and 96, 96, and now I'm done. So the common multiples are 24, 48, 72, 96. That would be the answer for part B then as well. So part A, the answer was 24, and part B, the answer is 96. And now we move on to part C, which is you had to, if you ordered 3 bunches of each kind of flower, how could I get tables and identical arrangements of flowers? So let's take a look at that. This one you would have solved using the greatest common factor. When you did three bunches of roses, you'd end up with 36 roses. If you used 8 lilies, you would have 3 times 8 is 24. Now we find the common factors. 1, 2, 3 is 4, yes. 6 is 9, 12, 18, and 36. I can check my work by making a rainbow. 3 times 12, 4 times 9, and 6. Oh, makes this a square number. And now 24, 1, 2, 3, 4, 6, 8, 12, and 24. I could check that. 1 and 24, 2 and 12, 3 and 8, 4 and 6. So this one works. It's a composite number, but not a square number. And now I could, going here, I could find any common factors. The 1s are common together. The 2s are common. The 3s are common. 4s are common. The 6s. Lots of common factors in these two numbers, and the 12 are common. And maybe you discovered that all of these factors would work. So I could divide, I could use 3 tables. I could have table 1, table 2, table 3. And in each table, with 36 roses, I could give 12 roses to each table. And then I would give, so this I can give 8 lilies to each table. But the question is, what is the biggest number of the greatest number of tables I can use? So for that, all I need to do is go to the greatest common factor in this case, which is 12, which means now I have 12 tables. Put in a nice array. And now with 12 tables, I'll divide the 36 by 12. That will give me 3 roses at each table. And divided by 12 is 2, and 2 lilies at each table. And that's how you would solve this problem.